Hi everyone. Hello. I'm Rashmi V Abbigeri. I'm from India and I'm working as a lead developer in OpSci. So, what is OpSci? What are we doing? We're building tools for scientific community for them to incentivize and reward impacts. So, give me. Oh, I just need to. Okay, okay, okay. So, we believe that with proper incentives, we can um, we can like encourage reproducible science practices and like provide verifiable impact. So how do we actually do that? So, so decentralized science has like roots from open source and open science. I know that decentralized science is very different. Michael just talked about it. So um, what is decentralized science and what do we want to do? The impact that open source had on software development, we want to have that impact with decentralized science on the scientific community. So there are many ways which blockchain can help solve uh, problems in science. So let's take a look at it. So it can help us like find new ways to cooperate, and then it's more like encourage more transparent incentives. Like in GitHub or anything, the code that developers write is like transparent. Now, what if the research that research scientists do, what if it's transparent from like the step one of collecting the data sets to do research and to writing the steps on how to do it and the whole process of what they do research. So this is helpful because if that the whole thing, the whole process is open sourced, people can, other scientists or like other scientific community or people who want to do research can like help, can like learn from it. And the people who are like advanced and professionals can also see, okay, is this possible? If there's any way to do it, or is this right, or is this wrong, or is this can be improved upon? It's just coordinates on one mission to improve science. So we can also store decentralized data and metadata storage. DBDAO, yeah, is one of the products to do that. So verifiable research objects and new forms of identity management. Um, so what do? We are trying to solve three problems. One is that the research community like isn't really incentivized to share the data sets. Uh, and if we want to have a revolutionary impact like what open source had on software development, if we want to have that similarly on the scientific research, we need to open source the science and research and data sets that we use and do. So the lack of reproducibility and uh, reliability in scientific research, what is that? So the reason most of the research is kind of like not reproducible and unreliable is because the data sets that they uh, like researched upon is not available. We don't know whether the data set that they did research on is like good, is it of good quality, is it fake or is it good, something like that. And if we have limited access to what these steps are involved in research and data sets, we don't really have an incentive uh, to just like verify the research. The reason verifying research helps us, it's like it helps build credibility of that research. Say like, for example, if cloning is possible, it's someone, there are like 10 other people who wrote, okay, these are the steps of cloning, and how do we know which one is right? We need to verify it. For that, the researchers need to share how they concluded that cloning is possible in that particular way. So we need to promote and incentivize sharing of data in the research community. So, so yeah, as I said, scientific data is not shared among peers, and in fact, it's less than 10% of it's shared. The reason this happens is like there's no proper incentive for them to do that, and because the scientific journals like help promote, hey, there's new and exciting, uh, publish a new exciting journal like which is catchy, which is like newsworthy, but there's good work to be done in like improving upon research that's already been done, and then just like chasing, oh hey, this is the new research that I've done, even though it's even one thing to know is like we might even not know whether that research is reliable or not. So another reason is like even if scientists want to share the data, there is no standardized protocol. Like say one research scientist may collect and organize the data in one specific kind of folder, and the other person like has a different folder structure. This slows down everything, and there needs to be a standardized protocol of sharing data. So that's one of the reason. And there is lack of resources to properly manage and share data. So in scientists are dealing with like terabytes and petabytes amount of data. So the Google Drive and those Google Drive, OneDrive, and all the other storage in Web 2 doesn't really support that. Like 15 GB for free, it's really not much. And for research, it's really not much. So we need a open source like archival platform where we can store any amount of data, and it's open and it's standardized, and people can access it and verify it. So, and yeah, the major cause, the one of the major impact uh, that not sharing data has had, like because of that, there's 70% of research that is not being replicated. And this is like, say a research needs to be implemented in a business, like hey, new method of creating chairs or something, and like easy, there's a new raw material or like mining method. So businesses like quite spend a lot on like actually implementing these steps and like making sure what's actually said in that paper can be done. So if it's like if the data is shared, it's like people can verify it, and then like say, hey, this is replicable research, and it's proven, and many other people who are not connected with the researcher are like have implemented it and have been able to successfully replicate the results and reproduce the results. So if that's not possible, like the reason uh, it's like they lead to a lot of errors and like wasted efforts in businesses, and even just like you would be just, if a research is not replicable, it would just be like some news, right? It's like some fancy news, like hey, something can be done in this way, or like like a news article. So, and also, AI and ML models are only as good as the data that they're trained upon. So one of the major and the popular example, which is like Neuralink, they they are an company which are like operating with brain neuro interface, and this is important research, right? Like they're implementing something significant that can have good and as well as bad impact on humans. So if it's decentralized, other people can like maybe think about things that Neuralink company has not been thinking about. Like we can help prevent some of the errors that Neuralink might face later, or like what happens is like, yeah, sure, Neuralink bears the consequences and risks of like them running into problems later, but there are also like collateral damage. When it comes to important things like Neuralink or like neuroscience brain neuro interface, humans would be collateral damage, our data and our lives would be collateral damage. So we need to not just be focusing on the quality of the data set, we also need to have like focus on infrastructure and the access of those data sets. So what's the solution? So one of the approach that we took was like, hey, people are having trouble publishing and sharing data sets. And one of the thing was like, okay, they don't have 15 GB is not enough. So let's make it like no limit on the size of data sets and allow them to like just publish any amount of data on blockchain, not on IPFS and Filecoin, and they can archive it. It's like permanently stored. So but we did create that. We quickly ran into a problem like uh, of needing an identity. If it's just connect wallet and then publish a data set, it doesn't really make anything. It doesn't really serve anything. The For that reason, we went on to create an identity too. So just a brief thing, OpSci.io is the open science community autonomous society that we are, and Verse and Commons are the two products that we are providing and we're building. So Verse is the identity solution that I was talking about, and Commons is the decentralized archival platform. Okay, so let's take a look at what we have created. This is what we're building. So how do I play it? Okay, thank you. I don't think, yeah, I don't think this one has sound. Okay, so this is a landing page where one can go and create an identity, and it takes them to a modal where they can connect wallet, continue with Orchid, GitHub, or Google. So next, once they create an identity, they can choose that whether they can be public or private. Okay, private is still coming soon. By default, right now we have a public identity. So then they move on to create a profile. Okay, real quick before we continue, this Verse is a decentralized identity registry. We want Verse to be adopted as like the one academic credential that one has on like in the whole scientific community. So how we do that? There are many profiles, like academic profiles, like one which was mentioned is Orchid. It's popular, but not really that popular because it's mutable. Like say, I, Rashmi V Abbigeri, I created some research and I might have not put that up on Orchid, but someone else can claim that, hey, I am Rashmi and this is my research. So this is, we can't have that, right? So we also want to like have on-chain actions to be recorded with their academic profile. Like as DeSci progresses, we would need to record all that and then just like have one interface where everyone can see it and just like view what they have done in science. Oh yeah, okay, it's working. They upload an image, just simple creating a profile and username, and then they have some questions that they need to answer, like, hey, what scientific community are you part of? Chemistry, biology. I personally love chemistry, especially organic chemistry. What is your role? Like, are you working in applied, experimentalist, peer review, anything? Okay, so we just have like a short about you description that they can also update. Now, so academic credentials like Orchid, developer credentials, social and community. They can link all of these accounts and create one profile for DeSci, their one interface with DeSci. So with Orchid, uh, in their profile, they have information of where they studied, what research they published, and what is their qualifications and what what article or like what research that they peer reviewed on. And we actually like put all that and put it in a one interface, one profile. Okay, yeah. So this is like combining on-chain identity with the scientific academic identity. Okay, this society is something later to be discussed. But yeah, so once they have an identity, we at Commons we are using this identity as a gate. So in order for someone to publish a data set and archive that, they should have a worse identity, and then they would be able to do that. Okay, so what are societies? Societies are like, say, a group of communities. Like our founder, Shadi, he belongs to neuroscience community, and like say, I create a society of like chemistry research and stuff like that. We can create a society, and all these on-chain decentralized science academic identity can belong to a society, and then they all can like help each other to peer review each other's research and like verify it and like reproduce the results that each other do and stuff like that. Okay, so yeah, this is to be done. We're still working on it, and the functionality, the front end is ready, but the functionalities need to be done. Okay, so this is the profile. This is what it would look like. So here, okay, you have an profile which is verified by Holonym, and okay, ignore the Holonym part right now. So Verse was built upon the early stages of Holonym. Holonym is a ZK-proof decentralized identity. Okay. So, okay, why is this profile important? Why is an identity important? Now, one of the thing that we discussed is like we repeatedly discussed, that was sharing your data, and this helps like replicating results, reproducing the scientific research and everything. Now we need to have a way of like recording all that, and it needs to be shown here. This is something like this helps a community, scientific community in a way, and all that is recorded on one platform. And based on how many impacts they have, based on their actions in the scientific community, which is recorded on this profile, people can be funded. People can use this profile to like get funds and like say, hey, this is my resume for my academic, and you can view what I've done, and just like go on. If you think that what I'm doing is valuable, and if you were willing to bet on me, anyone can fund them. Um, okay, I'll close this browser right now. Yeah. Oh, this is one of the things that I also wanted to talk about. Hypersearch. So we talked about impact certificates, and I'm sure like other speakers also spoke about impact certificates. So when we pull the data of the research published from ORCID Identity, we mint each of their research paper as an hypersearch. So when anyone interacts with this research paper, like say they do peer review on it, and then they like, hey, they say that this research is verifiable, this research is reproducible, and say someone else just like backs it, like upvoting. This is all, everything is recorded with the hypercerts, and hypercerts come with the ability to get funded easily. So if someone wants to just fund this research, like say, hey, black hole waveform catalog is something that I am interested in, and I want this research to progress, they can just fund it, and then it goes to the person who's like working on it, and then they can use it to show what then they can, like, once they receive the funding, they'll be obviously working on it. They also update what research is being doing after they receive money. And like, you can kind of think of as like each research paper as like some project that they're working on. And once that small project receives funding, they keep updating on their progress so that they're transparent with it. Okay, moving on to next.
So yeah, the time's running out of time. So how long will it take?
2 more minutes.
Okay, yeah, sure.
Sorry.
Next slide.
Yeah. Okay, so these are the links for Words. You can check it out, what we're doing at words.opsci.io, and Commons, the dataset archival platform. This Commons actually has an MVP where you can connect your wallet, you can connect your ORCID identity, and then have and archive a data set. Right now, we are people can archive the neuroscience datasets, which is we actually validate the datasets on bits so that it doesn't just become like some storage platform. So bits is a brain imaging dataset standard. So yeah, that's one of the standards that we support. We're also working on supporting all of these standards that we have like in different fields. Yeah, this is what we want to do. The future of science will be open source, pluralistic, and impact driven. And it's not just like gated and based on like word of mouth or anything. So this is our team, and that's me, and that's the founder. Real amazing group of people. You can scan this QR code to waitlist your DSI profile, and as I said, Verse is still being built, so you can just like type in your forms and provide your information, and then we'll invite you once we're ready. And you can connect with me, and this is my QR code. I am Rashmi V Abbigeri on Twitter, and Rashmi V Abbigeri also on Telegram. And yeah, those are ways you can contact me. Okay, thank you, everyone. If you guys have any questions regarding what I just said and any confusion, anything, just come and speak to me. I'll clear it up. Thank you.